Okay, everyone, thanks for joining today. You probably saw the notice come up on your screens. We're recording all of these sessions and making the videos available online so that people can review them. Yeah, thanks for joining today. We've got a pretty full agenda today, so we'll see what we can get through. We're first going to hear from Rich Farrell, who's going to talk to us a little bit about the Education Committee's experience with self-publication, because we're kind of weighing our options for where we're going to publish or how we're going to publish the 4th edition. And then we're going to tackle potentially 2 technical proposals for changes to the taxonomic system. So we're going to look at limnic materials in organic soils, and then we're also going to look at assigning drainage classes to non-redoxymorphic soils. So with that, I will turn it over to Rich Farrell and ask him to enlighten us about publishing.
Okay, thanks, Dan. So yeah, we took this on probably the beginning of 2018 at the CSSC meetings in Niagara Falls. Basically, at that point, we had decided that we wanted to go open access, and so we played around with different ones, and Pressbooks was the version that we decided to use. Part of that was because most of the universities used it. So UBC was using it, the University of Saskatchewan was, Lakehead, where Amanda was. That was the one we decided to go with. And so if you look at the address on our book, it always has like a USask part to the address. It's because it was entered through the USask license to Pressbooks. You can buy a license for it, or you can just find, like Guelph has I'm sure Big Guelph probably has a license for it. But that was how we accessed it, was through that. And then the main thing was just sort of deciding who was going to be involved, what we needed an editorial staff. And so Dan Pennick had brought the idea forward originally, but Dan was no longer involved. And so Fran Wally picked it up, and she asked me to help out with the editing. So I said yes. And then Maya Kurzik and Amanda Deschamps and Maxime Paré all sort of decided that they wanted to be part of it. This all happened at the CSSC meetings. We had conversations during the week of the meetings, and they came through and said, look, we'd really like to be involved in editing this. And so then we just started having meetings to determine how it was going to put together. So first thing was to just assemble an editorial team, and then determine, were we going to go open access or were we going to go hard copy? And the consensus from everybody was that part of the reason for doing this was that textbooks were really expensive, and we wanted to have something that was going to be easily accessible for students to make it more usable. And so we decided to go open access. And then for us, we secured some financial support. So we had the CSSC gave us some money to do this. We had some money from the Soil Science Society in Quebec. We had support from BC Campus, which is the open access group at University of British Columbia. I forget, and the University of Quebec in Chicoutimi, where Max is, also gave us some money. Now, most of that money funding we got was for the French translation of the textbook, which we're still finishing up. But we had some because we thought we might have to buy licenses for, we thought we'd have to buy a license for Pressbooks. Turned out we didn't, because we could do it through the university. We didn't know if we would have to buy anything like photographs or get permission for that sort of stuff. In the end, we wound up using it to hire a couple of grad students who did work on the copyrights. Every photograph in it, every graph, every photograph, everything that was graphics had to have copyright. We had to know that we had copyrights. And so that was a big job. So we hired a grad student who basically went through each file, each photograph, and then checked copyrights to make sure that we had it, or that it was something that had done. So for one of the chapters, say the digital pedology one, Brandon made a lot of the maps himself. And because he made the maps, he just basically assigned over the copyright to the fact that they were completely open access. So the next big thing was just identifying what chapters we're going to be in. You've already got that, you know what you're going to have, the different soil chapters and everything, and identifying who the authors and co-authors were going to be. And then we assigned editors to the different chapters so that people weren't swamped there. So like I edited 3 of the chapters, or 3 or 4 of the chapters. Maya did, Fran did, everybody else did. The big thing was sitting down and just developing what were the guidelines for the authors. What did you want? What do you want the chapters to look like? Do you want them to look like the way they are in the current version of the book, or do you want them to look differently? And so it was sort of just to develop those guidelines. Is there a limit? How short you want a chapter? How long you want a chapter? Limits on graphics, things like that. Just sort of putting together guidelines for everybody. Not that everybody followed the guidelines that we gave them, but it was we did put them together and get them out to everyone. And then the biggest thing was putting together a timeline for submissions and reviews, because everything came in and then we sent them all out for review. We'd get the reviews back, send them out to the authors again, just the standard review process. And you have to be flexible with it, but at the same time, if you don't set firm deadlines, you don't get things from people. So it's okay to be a little flexible up front, but when it comes time to getting ready to hit publish, you need to be able to just have firm deadlines. Then the next thing was developing a data bank for all the copyright licenses. We decided to go with the CC by NC4, which basically means it's open. You can use it. Anybody who opens the book or opens the digital copy of the book can use the photograph. They're supposed to give you acknowledgement that where it came from, but that's it. Anybody can use it for whatever they put in their own notes. They can put it in their own textbook. You just can't use it for commercial purposes. So we had several people who said they were writing manuals and that they were going to sell and wanted access to the photos, and we had to say no, because you just can't use them for commercial purposes. If it was somebody who wanted to just take it out and put it in their notes for a class they're doing, then that's fine. It just can't be anything else. Then for us, the next thing was French translations and promoting the book. But those were the big ticket items on it. But I'll show you what it is. Can I share my screen, Dan?
Yeah, you should be able to.
Okay, so this is what it looks like. So this is in Pressbooks. This is our textbook. So this is the home screen that you get when you get to something like this. And I can go in and say, okay, I'm just going to organize it, and it'll tell you what chapters there are. And if you want to pick a chapter, you can just click on it and it opens up the chapter. Everything in here, the blue, the outlines, the size, everything is what we chose for it. And we chose a theme for everything, put it all in. The figures are here. This is the type of information that you'll get, and you need to put in the figure captions. The one thing that we learned, and I'll tell you about this, is chapters in this book got put in sort of a haphazard order. So when it came time in the end to change photographs, it was hard to go through a data bank that has like 500 photographs in it to figure out which one you needed to replace. So if you're going to do it, my suggestion would be put them in the order you want to use them in, because it's a lot easier to edit them. There are limits to them. They don't like photographs more than 2 megs in size. And so we had people submit photographs that were like landscape photographs that were 27 megs. And beautiful photographs, but 2's the limit for Pressbooks. And then you can come in and you can change the size. There's other information in here that you have to fill in for the copyright, who owns the photograph, what copyright your assignment you're giving it, all sorts of things like that. There's a library. I think we can go off of that. And so you see it has all the photographs. There's 468 photographs in here. You can pick any one of them, it'll come up, and then here you can text, figure number, caption, you can write in another description. If it came from a source, did you get it from so we have several photos that came from Ag Canada or Environment Canada, so they might have the URL address, who the authors are, the license, who adapted it, if it's something that somebody else took a photograph and then adapted it. So all this information has to be filled in, and it all gets put into a database at the end. So that's the easy part. And then, you'll edit a chapter, and then you can just hit preview and it shows you what it looks like. So this is what the printed version looks like. So it's relatively straightforward, easy to do. There's a table press. So this is where all the tables are. You can create the tables independently. What we had people do is we preferred to send us an Excel file that has the table. That's the easiest way. And then the Excel files can be copied into table press, and you can do some editing within there. But that's the easiest way to get them over. Same thing with the photographs. You just ask people to give you a high resolution, something that's a good resolution, but no bigger than the 2 megs, and then you just copy them over. That's easy to do. You'll have to fill in information on the book, title, short titles. There's all sorts of information in here. Subject matter. This goes to where it'll show up if somebody's searching online for it. So having the keywords, what subjects there are, who owns the copyright to it. Ours was it was a CSSS one, so CSSS is the copyright holder for this. Everything in it has this CC by MC attribution to it. So photographs, everything. It included, our chapters have photographs of all the authors, and those photographs are included in it as well. So if you're sticking your picture in there, there's somebody else can just pop it out and use it for their own thing. Those photos, you can change the license so that you can just say, no, you can't copy it. And a few people did that, just so it's about the book. But just to give you an idea how easy this is, I went in this morning and I created this. So here, I'll organize it. So there's 2 chapters. One, I have a PDF copy of the book, so I just worked off of that, and I created all of this. So I can go back here and say, okay, I'll come into this one, I'll visit the book. There's what it looks like. I can come down to the first chapter. This is what it looks like. It's right out of, so I basically took what was in the PDF form and copied it over. You'll go through, there are some things, so you'll see there's a place down here where the paragraph doesn't match up. So there's some editing that you would have to do to make it consistent. I picked the theme for it. So I just wanted something a little bit different than the one that we had been using. So the theme that I picked was just, you get to sort of choose what you want. So appearance, there's themes. There's whatever, 30 of them or so that they have in here for different ones. This one is called Anderson. It just looked kind of nice. So that was the one that I picked. You can change things once you're in it, but you just need to pick some sort of a theme. Then you just go back. If you want to go into the next chapter, it's the same thing. Just to give you an idea, this one has these in it. So, and this is right out of the PDF. I just copied and pasted right out of the PDF into Pressbooks for this. And they came up pretty nice. The thing is here, because I did that, you can't edit anything and you can't put information about what these are. So if this was something that someone created and there's a copyright to it, you wouldn't be able to put it on here because this was just copied from a PDF. Initially, what you would need to do is go back to this version of it. And at this point, you would have to insert a photograph. or whatever the graphic file is into this. And then you can edit it and add all the copyright information, figure captions, everything else that go with it. I didn't do that just because I didn't have them separately. And I just wanted to show you that it was, I mean, I started this at about 10:30. So it took me about half an hour to pull this together. And most of that was trying to figure out how to get a cover shot of the book that I could actually put into it. So it's pretty straightforward to do. If you've got equations, anything like that, that's when it becomes more of an issue, because anything that's equations has to be put in a different format. So we did all of the equations in the textbook through LaTeX. And so, you know, it was oddly enough that all the equations are in the solid physics chapter, and nobody in solid physics knew how to use LaTeX. So I had to learn how to use LaTeX to put all the equations in. But it turned out it's relatively straightforward. Subscripts, superscripts, things like that, when you copy over, you lose all of that. One thing that you can't do is copy from Microsoft Word directly into it, because when you do that, you're copying code over that is associated with the Microsoft Word. So there's this code behind it, the text that's there, and it can interfere with Pressbooks. So so we had people send us things in Microsoft Word, but then we just converted them into rich text format files, and then you can copy those directly over without a problem. But for some reason, they don't want you to do the Microsoft Word directly because of that coding issue. And a lot of it, especially if there's things like subscripts and superscripts and italics, bolding, things like that, the code comes over and it conflicts with the code that they have here. Things are relatively straightforward after that. You want to do this, you want to bold it, you just come up and bold it. I can go back and say, I want to change the heading of it to this. The size, everything will depend on the theme you've chosen, but you can always make them larger. So it's all the sort of editing tools up here are the same ones that you'd see in a normal word processing one. It's pretty straightforward. Because ours had a lot of subscripts, superscripts, equations, things like that, it was easier to just say one person's going to do all of this. So I did basically all the sort of copy editing for it. I took all the individual files and created the book that we have. Depending upon how difficult it is and how complicated the material is going to be, you could just come in and say, design one chapter, create the template for everything, and then all of the subsequent chapters will follow that template, and you can give permission to multiple people. So you could give permission to each chapter author to be able to go in and enter their own data. The thing is, if you give them permission to do that, you're also giving them permission to edit anybody else's stuff. So it just depends on what you're doing. Like we didn't, you know, we had 42 authors. We didn't want to have 42 people going in and playing around with things. So it was easier to just go through one person. But like I said, you know, this took me half an hour to do this. It's not that difficult to do. It's more, what are you going to do? So like all of these, everything here is through the University of Saskatchewan's license to Pressbooks. So that's the first thing you need to do, is decide, is there a good license for it? Is there a way to access it? I'm assuming that the University of Guelph has the same thing. Like I know UBC did. I know the University of Regina does. Yeah. So then if you've got that, it's easy. You basically have them set you up to, you know, all we had to do, we had to give them the title of the book and the names of the people who we wanted to have access to it. And then that was it. Right now, the book is, this book is private, so it's not publicly available. So the only people who can see it are the people that you've given permission to. So right now there's users, and so like the only user here is me. But if I wanted to add Dan, all I would do is take your email address, paste it into here, and then I would assign what the role is going to be. Are you going to be an administrator or an editor or what? Like the administrator has access to everything. You can change everything about the book. You can give editorial rights to certain ones, and then they have limited access to it. And other than that, once it's done, you just click a little tab that says take public, and then there you go. And it's basically done. And when you're all finished, what you basically have to do is come back and say you're going to publish it. There's some information. Where do you want to publish it? How are you going to do it? You're going to go back and say export. And then you decide how you want to do it. Do you want it to be a PDF for print, digital, e-publication? These are the different options. Click what you want, hit export, and then that exists. That's what it exists. So we did ours as a PDF for digital, e-publications, and I think it was the common cartridge one, because this links to Canvas. So if you're at a university and you want to use it for your class, this gives you access so you can copy things right into Canvas. The other ones, we just decided we didn't need them for it. You can do PDF for print if you want. And just to give you an example, this is the print version of the textbook. So do we just wanted to see what it looked like as a print version. And so Amanda had a copy made for herself from BC Campus. They're the ones who did the printing. Came out pretty nice. And so we bought copies for everybody who was on the editorial staff. And that was pretty much it. They're not cheap. It's still cheap as the textbook goes. It was $90 in shipping. So, but you can print them out, and it looks really nice. It did a really good job on it. So overall, it's not that hard. It's just being organized to put it all together. So it's just, the biggest part is the copywriting issue. It's doing that, and then just getting figures and graphics that have a high enough resolution to do. So we had a lot of graphs that came through. I think Graham had a couple that we wound up getting redrawn just to make them higher resolution. And so, what we did is we hired somebody, a graphic artist, to take those and just create high resolution versions of them. And so that was some of the expense with it. I think the whole thing, altogether, we put probably $15,000 into doing this. And the vast majority of that went for the French translation, because we had to hire 2 people who do who professionally do translations of science books. And so that was our biggest expense for it. But if you're not going to do a French translation, you could probably get by on this whole thing for 5,000 tops.
Wow.
Yeah, we have an advantage over the textbook, Richard, in that like the 3rd edition is going to be the foundation for the 4th. And so a lot of the material that we have is just going to be reused. And we're right now working with the current publisher of the 3rd edition on acquiring the full copyright. So we'll be able to just reuse anything that we want in the entire book to put into the 4th edition, and then just build upon that. And so, there's a couple of proposals for some new soil orders, for example. There's some editing that needs to happen in there and that kind of stuff. And then similarly for the French version of the book as well. We will have the French version. I've already got a couple of volunteers that would that have agreed to help with putting together the French version as well, once the kind of as on a chapter by chapter basis as we put the English version together. So yeah, it'll be a little bit different, I think, than your experience. Probably a simpler experience, but I guess all in all, what I really wanted to hear was that it was a good approach, and that you guys are happy that you went through that way, because we have been asked if we wanted to work with the current publisher to do even to do an open access kind of thing. Of course, that comes with a fee, and I'm not sure what that fee would be, but we haven't had them present to us what their vision would be if they did come on board to publish the book for us. But we were really looking for the flexibility that Pressbooks offers, in that, if I find an error, I can send you an email and you can say, oh yeah, that's a mistake. And you can go in and publish that change, and it's live. So,
yeah. And that's happened. We've had someone found a correction in one of the soil physics equations that was wrong. sent me what it was. I went in, changed it, everything goes live. The only thing is, when you do that, you have to remember, you have to re-export the book, because if you're doing it as a PDF that someone's going to download, the
Right.
change automatically is made to the version that's online, but the export creates different types of files that are then available to people. So like the PDF for electronic distribution has to be saved that way. So while you make the original change, you then have to remember to just re-export the book. And it you know, it depending on the length, like ours takes a while to do, because it's, you know, things this huge, and it has, you know, 468 high resolution photos in it, so it takes a while for it to do it. But other than that, the online version, the changes get made instantaneously. And we've had probably 6 or 7 people who found errors that we've just changed out, and that was it. So yeah,
Go ahead, there's a question, yeah.
Yeah, thanks for that. That's very informative. I'm just wondering about those changes you were just talking about. Does that mean that every time you fix a mistake like that, that it has to be saved as a version X plus X plus X or dot X or anything like that? How do you keep track of that?
No, we talked about that and decided that we would only change version numbers if we made a major change. These are basically people found a typographical error or something like that. And so we figured those are just small enough that it's just like, I have a notebook that I keep track of of the changes that I make. And that's basically all we do for that. So for this, we've had several people ask, you know, why isn't there a forest soils chapter? And the thing is, nobody volunteered to write one, which is why there wasn't one. So that's one of the things that'll come up at the meetings this year, is to see if anybody wants to put together a forest soils chapter, in which case we'll add that, and then this will become version 2 or version 1.1 or something like that. And then we'll change the title of it and everything. But for small things, we just decided it was too much work to keep doing that and keep them. And plus, every time you have a new version, if it stays online there, we're just eating up space at the university. Sort of is always looking over our shoulder saying, hey, you know, can you clean up some of this space that we've got? So it was easier not to do that and just make the quick changes, and then it gets saved as the same thing. So Graham?
Okay. Question, Richard, you mentioned that you had got hard copies run off. Is it possible to get that done if someone wanted to get a couple of copies, or how does that work?
Yeah, no, I can send you the information. It's just through BC Campus.
Okay.
So it's actually I think they actually print them at Simon Fraser University. Okay. So, but it comes up, I don't know if you can see it, but it comes up on the side and it just say BC Campus, open access. And so that's it. I was tested, like, what was it? Amanda made one just to see what it was going to look like, because we had no idea what the page formatting was going to look like, because it looks nice on the computer, but when I printed some stuff off on my own computer for PDF stuff, it didn't print out very well. But they did a really nice job with it. And we weren't sure if you could do bulk copies of it. So I had 15 copies made for all of the teaching staff here in the Department of Soil Science. And it was the same thing. I think it took 2 weeks to get all of them and have them shipped out here.
That's really good. We didn't have much of a problem at Laurentian getting a copy for all the soil science faculty, because they don't have any. So
yeah, no, it was I didn't expect it to be as nice as it actually is.
Yeah, so what I was thinking of, 2 or 3 or a few of my international friends, I could almost call it a Christmas present if I had enough cash in the bank, sort of thing. That's why I was asking.
Yeah, no, it's nice. So like, I had a copy printed for Dan just because he's the guy who sort of brought the idea forward and everything. So I'm meeting with him on Monday to give him a copy, just because I thought he should have one. Like Fran and Maya said, that it suddenly they were happy with the electronic one, but when they got a hard copy, it felt like it was actually real.
Well, I hate reading on the screen, so that's another.
Yeah, me too. So,
Yeah.
So no, it's
not the wrong word, but I get sore eyes.
Yeah. But I'll email you the information on how you go about doing that.
Okay, thanks, Richard.
Kent, did you have a question?
Muted.
I think
You're muted. There
Ken.
we go.
Not sure if this is the place to ask it, but I'm just going through all my slides and organizing them. Is it too late to get some of my photographs into this? Because I've got some really nice photos
Into which?
into the new book.
That would be you, Dan.
The textbook or the classification book?
I guess the classification book, because we're talking about the textbook.
Yeah, so right now we're just talking about their experience with publishing, because that's the direction we think we're going to go with the system of soil classification, the next book. Yeah, that's a discussion for a future meeting, Ken, but yes, to answer your question, we will be putting out a request to practicing soil scientists for their best pictures of soil profiles that we could use. I would like to replace a lot of the photos that are in the current textbook with updated new high resolution photos. And so there will be a call that will go out to start accepting donations of photos so that we can review them and come up with a list of to replace the ones that are in there, maybe supplement as well. So
now that's always been a limitation of the current text, is that some of the photographs don't really fit, especially some of the landscape photographs. And a really good set of soil order photographs, even at the highest level, would be fantastic to for you collectively to put into the new version.
Yeah, because I've got a lot that that I have. I think I would like to get them in there before I get even older.
yeah, if you have your favorites that you think would be good for the book, then by all means you can send us copies of them, and we're just going to compile them. And at some point when we start to lay out the book and figure out what we're going to need in terms of photos, then we can start looking through the photos. But I think it's one of our agenda topics. I think it's in April. We were going to talk about graphics in general. So updating all of the figures in the book and updating the landscape photos and the soil profile photos. We're looking to kind of redo a lot of that stuff. So that would be great. Thanks, Ken.
Yep. I'm holding up Ken's book here just because it's very, very good.
Actually, I'm rewriting that right now, and I'm incorporating the information that's going to go into the 4th classification book. So adding the anthropologic order, and I'm going to be talking more about orders. It's going to be expanded from that first version. So I'm working on that now.
If you decide to go down this path, the other thing is I'm happy to sort of help out if you're doing stuff with Pressbooks and you're not sure what to do and everything. I'm more than happy to go on and do that and help out with any way I can. So. And it is like we're been having conversations. Ed Gregorich started some conversations with me about redoing a 3rd edition of the Soil Sampling and Methods of Analysis book as well. And the conversation now is, do we go open access or do we go back through the publisher and everything? And part of that's going to be copyright issues will be a big thing if we decide to go open access. So. There
is an open access version of that book online, but I don't think it's
yeah, I know. I've got one. So
so do I. I have the hard copy too, though, so I'm allowed to have the version.
Paul,
quick question here. In your experience, what was your experience with this 2 megabyte picture limit in terms of resolution when it came to printing your print copy of the book?
Oh God, they're gorgeous.
Yeah, so they blew up fine for the profiles. I'm just thinking of the profile pics that we've just now discussed putting into the textbook. Is 2 megabytes going to be sufficient resolution?
Yeah, I don't know if you can, like, these are ones from that Dan had given us for profile one. I mean, I was
Look-
amazed at how good they actually look on there. So I was surprised. And honestly, you can go over the 2 megs a little bit. They just we ran into problems because there's so many photographs. I mean, we have, like I said, 468 of them. And so, at 2 megs a piece, you're kind of like a gigabyte. Yeah.
Photos and file size and reports and books are always a challenge. Yeah. No,
Yeah.
I just thank you for your feedback. I just wanted to be sure we didn't overlook resolution needs here.
Yeah, and on the computer, I think they're sort of stunning. I don't know if you looked at it, but
No,
I mean,
I haven't had an opportunity. But
yeah,
I will now.
but when you go into the online version of it, the photographs really are remarkably good. So,
Yeah.
All right.
and like I said, you can go over that, just not with too many of them. So we've got a few that are probably in it 4 or so, and that was about as small as we could get them.
Yeah, like I think we've only got a couple of dozen right now of actual like landscape photos and soil profile photos, and then the rest are just figures, and those figures and diagrams are fairly small because they're just vertices, right? But it's the images are the ones that'll be the struggle. But like you said, like we're not going to have 400 photos in our manual, right? So
yeah,
perfect. Thanks, Richard, for taking the time today to talk to us about your work, and we probably will take you up on your offer to help with Pressbooks if we do run into some issues. Although we still have to make that decision.
Yeah,
Richard. Actually, I think it would be really good to send that link for people to print a hard copy of the book. We should send that out through Nancy to the CSSS membership. It would be interesting because I think a lot of people might just go ahead and order a print copy of that book.
Okay. No, I can do that. I'll contact. We have a council meeting next week. I'll make sure Nancy gets the information. Paul?
Yeah, on the business of the printed copies of the text, I recall in some conversations suggesting that would be a good prize to use for the undergraduate award. And I don't know whether that ever got picked up as a suggestion.
Yeah, we're having conversation. That was one of the reasons that we had that I got 15 of them made. We wanted to see what they were going to look like, how long it took to do it and everything. And they came out really well. What we're trying to figure out now, we were unsure if CRC Press donated the books that we gave out as the awards or whether we were buying them from CRC Press. And so Diane's looking into that to find out. If we're buying them, then it's just as easy to pay for this instead. And that's probably what we'll switch over to this year.
Thank you.
But no, that was a good idea. Several people brought that up, and I think a lot of the students, since they're undergrads mainly, I think they really appreciate that more than the methods book.
Yeah, having had a couple of students who've got the methods book, they kind of say, well, what are we going to do with this? Whereas with the textbook, when they're my age, it might still be on their bookshelf.
Yeah, no, it was a good idea. So that's our next thing. So, and then trying to figure out with the methods one, what we're gonna do. I mean, part of that was with the second edition, the society actually made $28,000 from sales of the book. So, there's the trade-off. We lose the 28,000, but you probably gain more access, that it becomes more accessible to people, and is the accessibility, like for the textbook, the accessibility was the big thing, not making money off of it. With the methods book, I don't know. I'm leaning towards just going completely open access on it. I think that's the way to go. So, but we'll have to, a lot will depend on what happens with CRC Press and the copyright issues on some of the everything. Because if we have to redo every figure in it, it might become prohibitively expensive. So,
right.
But yeah, no, if you decide, the big thing really is sort of picking the design. What do you want it to look like? So like, we played around with different templates. We built one chapter and then used that chapter to change templates and change themes just to see what was going to give us a nice visual look to it. And I think the one that we picked in the end really worked out well for the textbook. But I think that's the first thing to do, is just have somebody build one chapter, whether it's the introductory chapter or anything, and then use it to play around with the themes, decide how you're gonna do it. And then from there on, that becomes your template as you move forward, and that makes things a lot easier.
Great. No, it looks good. I'm liking it more. All right.
Yep.
Thank you very much, Richard.
Okay.
So we will switch gears and we will get into some of our technical stuff.
Okey-doke.
And so feel free to stay and argue about soils with us if you want, Richard. It's always-
I've been living on Zoom this week. I've been in meetings from like 8 o'clock in the morning to 2 in the afternoon every day this week. So I think I'm gonna zoom on out of here and just go find something else to do. So. So thanks a lot for having. I hope it works out. And like I said, I'm happy to help any way I can. So take care.
Thank you.
All right. Bye.
All right, so we will shift now and we'll get into the first of our technical discussions today. And so I'll invite Rafael to share his screen. He's going to present the paper on Limnic materials. Perfect, thank you.
Can you confirm that you're seeing the presentation in full screen mode?
Yeah,
And
seeing it in full screen and we can hear you.
Yep. Thank you very much. I'm just getting ready my camera. Working, yeah, okay. So hi everyone. Today I will be presenting the proposed modifications to the organic order that were outlined in the article that Daniel and I have written. So we will mainly be talking about a better recognition of Limnic materials in the upcoming 4th edition of the Orange Book. So in this short presentation, I will give you the background and context of the problematic, define what are Limnic materials, comment on the implication of the proposed modifications in an agricultural context, and we will also look at the estimated extent of land that could be affected, supported by some example profiles. And yeah, of course, we will conclude with the actual suggested revisions. So here are some pictures of Limnic layers. Some are still fresh and others are showing dried up layers. So the Canadian soil classification system uses the term Limnic to describe any layer that is 5 centimeters or thicker and composed of one of the 3 materials here. So we have coprogenous earth, which comes from aquatic plant debris modified by aquatic animals, diatomaceous earth, composed mainly of shells of diatoms, and marl, composed of shells of aquatic animals, and calcium carbonate precipitated in water. So it's a sedimentary layer, which can be clearly observed in the images here. So in Canada, we could argue that coprogenous earth is the most common type of Limnic layer. Its notation would be OCO. So the nature of a OCO layer can be quite variable. It can be more or less pure as any other layer depending on the transition, but can also contain more or less plant debris. It is also quite variable spatially, but we'll talk more about that later. So the main characteristics of coprogenous layers are that they're gelatinous when wet and can dry almost irreversibly. So they can also be organic or mineral in texture. They can range from very acidic to neutral or alkaline, and they can be rich in sulfur and release sulfuric acid when oxidized. In our article, we presented data to justify the proposed modifications. So this data was collected from multiple soil profiles in Ontario and Quebec, and coming from mostly cultivated areas. And the soil profiles were described by many entities, including AAC, Daniel, and I. So we can see from this sample of the analytical data that the chemical and physical characteristics can vary quite widely. For instance, the pH of the material from the sampled soil profiles in Quebec and Ontario ranges from 4.5 to 7.6. It should be noted that the CK or CG horizon that you see right here was left there intentionally because it's actually a marl layer. So as outlined in the CSSC, the collected samples range from organic to a mineral nature, with organic matter contents as high as 82% and as low as 4.5%. And in some samples where we measured the hydraulic properties, we can see that the KSAT is virtually at 0 centimeters per second, highlighting how impervious these materials are to water. And more recently, the materials have been found to be weakly to moderately saline. Oops, sorry for that, right here. So coming from a soil physics lab, I can confirm that water retention curves from limnic materials behave weirdly. As previously mentioned, limnic materials tend to be gelatinous when wet, but when they're dry, they dry almost irreversibly. Therefore, once they transfer the water to plant roots, this growing medium will not soak in more water the next time it will rain. So quite on the contrary, they tend to behave like impervious layers, leading to a perched water table. And as you know, roots need oxygen to develop. So that's the first issue. Number two, there's an interesting study from 2017 that detailed the impact of saline soils on vegetables. So with the data from Quebec, we can say that the increase in soil salinity that is related to limnic layers has already low to moderate effects on crops. The pH and potential release of sulfuric acid can also be problematic for crops. And at number three, you won't put as much energy and money to apply conservation methods to a limnic terric mesosoil as you would to a terric mesosoil, pretending that the mineral layer starts at the same depth. Because one is more valuable on the long run for sustainable and long-term food production. When it comes to financial transactions, and there are a lot in Quebec at the moment, knowing that you're dealing with a, let's say, limnisol versus a mesosol can really impact the price of the final decision. Oops, I'm sorry, I think I missed a point. And yeah, so as a conclusion, coprogenous materials might not meet the definition of soil as outlined in the CSSC, since they likely would not be capable of supporting plant growth. So the rationale behind the proposed taxonomic change are: one, coprogenous earth and limnic deposits in general are likely underestimated in Canada. Two, soil survey has traditionally focused on agricultural soils and wetland deposits, and organic soils were less intensively described and mapped. And three, given their undesirable physical and chemical properties, these materials have serious implications for agricultural management. So here's the potential extent of limnic soils in Canada with a table estimating the total acreage per province. So reaching a total of around 32,000 hectares, we can see that it's quite a significant number. So right before we look at these suggested modifications, here are real examples of soil profiles found in Quebec and Ontario. The common point between those four examples is that they must all be classified as terric humisols according to the third edition of the Orange Book. What would make more sense is to reflect their real features. So if the modifications are accepted, it would give more weight to the limnic material that is clearly prominent in these soil profiles. And for those less familiar with the organic order, the soil profile here consists of three tiers. The first being from 0 to 40 centimeters, the second one from 40 to 1.2 meters, and the third one from 1.2 meter to 1.6 meter. So the gray group is defined by the dominance in the middle tier. So here you can clearly see that it is problematic when the middle tier is completely dominated by limnic material. So, okay. So the proposed modifications to the CSSS, we would like to suggest a modification at the subgroup level and allow the use of limnic subgroup in combination with the terric subgroup. So let's look what it would mean here. So as outlined in blue, the problem is that the limnic subgroup keys out after the terric subgroups. It never stood a chance to be an important part of the soil description. So here we would have to add a terric limnic mesosol in this example. So there are four major suggested revisions. The first one would be modifying the key to soil orders to allow for soils with dominantly limnic materials to be included in the organic order, and including limnic materials to be counted towards that requirements for organic soils. Number 2, adding the Limnisol grade group to accommodate organic soils, whether middle tier or middle and surface tiers are dominantly composed of limnic materials. Number 3, adding subgroups under the new Limnisol grade group. And 4, further integrating limnic at the subgroup level in the fibrosol, mesosol, and humusol grade groups. So without reading everything, you can see the implications of the revisions in the key to soil order section here highlighted in yellow. And here it would be the proposed addition of the Limnisol grade group. And here the modification of the subgroups, allowing to combine Terric and Limnic subgroups. Also, please note that there will be no modifications to the Folisol grade group. So the same changes would also be made for the mesosol and humusol subgroups, of course. And finally, we would need to add a new grid group, the Limnisol, and it would require its own section in the key to subgroups section. So you can see here the structure for Limnisol subgroups. So, of course, I would like to thank Daniel for leading this initiative and for allowing me to collaborate with him and letting me present the slide deck he presented today. Thank you for your attention. I'm sorry. And we would also like to acknowledge the contribution from previous collaborators, namely Luc Lamontagne, André Martin, Claude Lévesque, Lucie Grenon, and Michael Leblanc. So thank you, everyone. And Daniel, before we go on with the discussion, have I forgotten to say something important, or would you like to add something?
No, I don't think so. No, that's good. You covered the I think what was in the manuscript. And so we would open the floor for some discussion if there's any additional questions or if people have comments on the manuscript and what was in it. Richard?
Yeah.
Yeah, they can hear you.
Can you hear me okay? My questions are actually, I think it's a good idea in principle. I have no problem with that. I'm just thinking about the way that you've proposed introducing this into the key at both the grade group level and the subgroup level. We're normally working and visualizing a dichotomous key. And if you look through the order level, the dichotomous key follows through until you get to the end, other soils. No other characteristics, other soils thrown in the regisols. And when we're looking in most of the, I didn't look extensively across all of them, but I think in most of the great subgroups, we always come down to the end and other soils, and often it's Northic or something like that. Most of the great groups, and I was just looking at this morning, also have that sort of structure where you get down, you've eliminated 2 or 3 great groups, and you get down and says other whatever, and it drops into the default.
Yeah.
I'm seeing here that you throw in the limnic at the end of the list, in the dichotomous list. I'm wondering if it wouldn't be more suitable to perhaps put it just under the fibrosols, because it's
For this is for the subgroups?
for the great groups.
The great groups.
Yeah.
So I don't think it matters, to be honest with you, where it goes, because the organic order is structured so differently than all the other orders.
Yes.
In that it's just based on the level of decomposition of the organic material. So you don't really, it's not really it's not this, it's this, is that there? No, is that there? No. So it's kind of it's structured differently. So I don't think it only matters at the subgroup level, I think, where we integrate the limnic materials within the order. At the great group, at the great group level, it doesn't really matter, because it's either humic, it's either dominantly humic, mesic, fibric, or it's limnic. That you have 4 choices. So I don't think it really matters where we put it in terms of the great group key. Like I think right now I'm not sure where we were actually, I'd have to go back and look to see exactly where we proposed to insert it, but.
On that note, Dan, on that note, I mean, I've got my Orange book open in front of me and I'm looking at the dichotomous key here and the key to great groups. I mean, currently we go folic, fibric, mesic, humic. I would actually argue maybe throwing limnic right at the start in this trend, because just on the basis that limnic materials are going to be more rare in terms of their distribution in Canada. one could argue folic is more rare than fibrosol, mesosol, and humazole. It might be easier to discount the rare one at the start of the list rather than leave it to the end of the list. Kind of in the same sequence we have gone with the folisols versus fibric mesochemazole. Other than that, having read the paper and listened to the presentation, I see no reason not to include this.
Yeah, I'm just looking at that. It's slide 14 again. You're right. The limnosol great group is being proposed to be put at the bottom of the only thing I would say in terms of the order of those is that we just keep the wetland organics together, and the upland, I know we don't like the word upland, we'll say the non-saturated organics separate from the saturated organics, and the limnosols would fall under that. So whether we put the limnosols above all the other materials or we put it at the bottom, I'm fine with either way. It doesn't matter to me where it goes. In the end, we get to the same answer, I think, anyways.
My logic was exactly what you were thinking, is that the so-called upland is different than the underlying four, which are more wetland associated, but that the limnic layer is a substantially different component than you would have with just your typical PD deposit.
Yeah.
And
But again,
dichotomous key is dealing with that we're pulling out deviations from the typical or the orthic version.
Yeah.
And that orthic is always falling out at the bottom.
So move limnosols up to second place. It's better than last place. Constantine.
Okay, back to that presentation. If it is possible to share it back, but there was a table showing organic matter content in those soils, and I remember at least one profile in Ontario that was way below 30% organic matter. How this soil would be classified in the organic soil order, if that's the case?
Yeah, so that's a very good question. And if you read through the definition of organic horizon, so the O horizon definition, by definition, it has to be organic. But then if you go down and you read the definition about the OCO horizon, the OCO horizon is a magical exception to the organic rule, and it can be either organic or mineral. And so if you look at the American system, for example, they don't use O to describe limnic materials. They use an L horizon for all limnic materials. And that's how they can treat those separately from the organics. In the Canadian system, we use O horizons. Note as well that there's more differentiation between limnic and organic in our system, in that like a marl horizon is actually denoted as a CK, but it's called a limnic deposit. And same thing with the diatomaceous earth. The diatomaceous earth is a C horizon with no suffix attached to it. And so, even that is confusing in that those are all considered limnic deposits. Two of them are denoted with mineral horizon notation, one of them with organic, and the one that is organic can be mineral or organic. So I'm not sure of the historical integration of limnic materials into our system. I would argue that it was done poorly. This only addresses a part of the problem, I think, and actually recognizing that these materials exist within our soils. But you're right, it violates the rules of the organic order.
Yeah, so I know it may be a bit late in the procedure, but can we challenge that aspect and basically limit the organic order to presence of all horizons rather than CK horizons like marl and caprogenous?
Right, but okay, note that just because, so that those materials still would classify out as organic soils despite the fact that they are mineral. Same thing in the American system. So there's this weird little caveat about limnic deposits because of their odd nature. So yes, I agree with you. I mean, maybe we should revisit and do a little bit more about the horizon nomenclature. I guess the focus of the current work that we were proposing was simply to, at least at first, acknowledge that these materials could actually be dominant in our organic soils, and that should be recognized when we're classifying them. Revisiting the horizon nomenclature, I think, would be another project all to itself in terms of how do we actually include, or how do we deal with the horizon nomenclature of limnic materials in general, because they are a bit of an exception to the rule. I do have a comment from Jim here in the room.
Yeah, I just had a question, begs a question to me from terms of the genesis of that material. Can you get a limnic horizon associated with a non-organic soil?
No.
They typically don't. So that to me says that it has to be with the organic soils.
Yeah, they don't occur. Because they're a lake-based sedimentation process of some sort, whether it's an organic sedimentation or a mineral precipitate or organic organism accumulation. But yeah, it all has to do with the lake environment. There's actually considerably more work done in Europe on these soils than there is in North America. Maybe they have more of those deposits, but in the paper we highlight a few different classification systems that are much more advanced for these materials than what we use here. I'm looking for hands. Paul, yeah. You're muted.
I've run into these in Western Canada several times, almost exclusively associated with organic deposits. Listening to the two arguments, Constantine makes some good points. I suspect that your colleague there off screen, his comment about the association with organics and basically the aqueous depositional environment is probably the historical imperative to put these together because of their rare and complex, confusing nature in terms of where to put them. Perhaps there is an argument, but the solution is then what? Does it become its own order? Is it a special case? I'm not really sure where to go with that, but I would put it out to the group is the overarching issue of whether or not it's got enough organic carbon in it to qualify as an organic layer, something we want to tackle now, or is this proposed methodology by Dan and I'm sorry, the wonderful young fellow that just presented, kind of a transitional gap in this, like a transitional measure in this version of the Orange Book with an eye to revisiting this going forward. The one thing I noticed about the carbon contents is they're highly variable. And as someone who's, found these in the field, you're not going to be able to determine how much organic carbon is in any one of these layers at any given time without doing the chemical analysis. And that's not an argument not to worry about it, but maybe a consideration. They are fairly recognizable in terms of being able to identify them in the field. Given that it's been part of that system for a while, I think the easiest to implement is the proposed methodology, but Constantine does make a good point. Maybe we just don't give these enough, this hasn't received enough scrutiny because of its relative lack of abundance in the Canadian landscape.
Yeah, and I should say that the map that we looked at as well, that is a map that shows the current extent based on the soil maps that cover Canada. And so, that they're heavily biased in the fact that, these things are probably not well captured in our current maps. And so that is I would say that is our low end estimate of the acreage, 32,000 hectares. I would probably argue that it's going to be, there's substantially more of these soils that exist. They're just not commonly described. So
I would agree with that, especially in the Hudson Bay lowlands.
Yeah, and and I've looked at reports online, like consulting reports actually from around the Edmonton area. And limnic deposits are described in many places in wetlands around the city of Edmonton, yet those don't appear on any soil map. And so there are a lot of these occurrences. They're maybe not very large occurrences, but they do exist in these wetland environments. So we've got a comment here from Richard, and then we'll go back to Constantine.
So my comment really follows up with what Paul was getting at. And I think one of the constraints that we put ourselves in is that we've got this order called organic soils. And when we say that, we're immediately thinking, okay, it's the soils with these high amounts of organic material. Well, we've got a conundrum already. If you're going to create this limnosols, And if we recognize that limnic material could be diatomaceous, then where's the organic matter? I'm seeing this more as a need to maybe rethink what we're really trying to encapsulate in this order. And it's essentially soils that are developed or containing layers within the profile, which is an accentuated, concentrated concentration of materials that were laid down by organisms. And it could be plant and vegetative material, and that's the whole histosol side of things. It could be coprogenous, it could be the diatomaceous, or it could be the marl. And so, I mean, just this morning I was talking with Dan here about the idea that maybe reflecting on how we're calling this order to create some kind of separation. And I'm going to go out, stick my neck out on the line and think maybe we call this organosols as opposed to organic soils. And with the organo, more thinking from the organism perspective as opposed to the organic matter perspective. Yes, in some circumstances, it could be a high amount of organic matter that's in the profile because of the organism. But on the other hand, it could be some other constituent that's derived from excessive organism deposition.
And greater than 30% organic matter or 17% organic carbon is not a prerequisite for being classified in the organic order, because the limnic materials and limnic horizons are defined in our system as horizons that occur in organic soils. And so I think there's maybe a misconception there that everything in an organic soil needs to have more than 17% organic carbon, because that's just not true. Konstantin.
Well, from other perspective, this limnic material overlaps with what is called lacustrine deposits, mineral lacustrine deposits. And they are CK horizons. They are materials at the lake bottom, and they don't contain much organic matter, or they may, it doesn't define there. But if we need to separate those definitions, as marl is lacustrine deposit. You call it limnic, it's a specific fraction of lacustrine deposits. It's not an organic deposits. If you consider anything based on calcium carbonate organic, then you should include limestone and chalk deposits into organic soil order. They are also made by organisms, and they are also 100% calcium carbonate CK. Thinking out of the box.
But yeah, the difference, I guess, with the rocks that are made from these organisms or developed from these organisms is that they've become rock, whereas these materials are not rock. They're a sediment that's laying at the bottom of
until they are dry, and then they are rock.
Until they get compressed and dried.
No, until they're dry and they're impermeable, and they meet the more class 3, so like particularly hard. That's it. That's a rock.
Yeah, and
again, changing it.
I think the challenge too is how much detail do we want to get into with describing the nature of limnic materials or coprogenous earth within our system? Because if you look at some of the European systems that work on this, like they describe a gradient. They actually have a triangle, which includes calcium carbonate content, I think mineral fraction and organic fraction, that they use to classify these materials. Like there's an entire subdiscipline that studies these materials. And I guess the question becomes, is it a soil scientist's job to understand the full spectrum of those limnic deposits? Or is it our job is just to identify that there's a limnic deposit within a soil and it ends there? I guess it gets to the, there's how deep down the rabbit hole do we want to get in the work that we're doing? Or do we want to leave that to a limnologist who spends all of their time studying these types of things, water bodies and their deposits, right? So yeah, it's a good discussion. And I guess what we have to decide is within the scope of what was presented, whether or not we think that we're satisfied with that going into this next edition, or we're not. And we say, we're going to have to study that some more. Let's move it to the version 4.2 that comes out maybe in a few years. Paul Sanborn.
Yeah, so I have very little practical experience with these types of soils. I think I've encountered marl a couple of times, but none of the other things that would be covered in this. To me, it seems like a reasonable incremental refinement to be included at this stage. And this is always going to be a work in progress. And I sense that in a number of our discussions, we're going to repeatedly come up with the dilemma of, do we get every little possible connected detail perfect, in which case we kind of paralyze ourselves, or do we accept that it is a work in progress and that we proceed by incremental steps, as our predecessors did for the previous 50 or 60 years in the previous editions. So I'm happy with this. Again, that the caveat is I haven't seen a whole lot of these, and they're not that common in the landscapes that I have worked in British Columbia. Thank you.
Thanks. There's a couple of comments that just in the chat. I'm not sure if everyone's following the chat or not. I think we should give a range of organic carbon in defining OCO, and also typical content. The nature of its genetic environments appears more important than the rules. Yeah, and I guess that's the problem. If you look at any system that does classify coprogenous earth materials, a range in organic carbon is just one of the factors that is considered in defining those, and so it's tough. And I think that's why we have these, coprogenous earth materials as defined in the system, that they can be mineral or organic, because the range it's the full range. It can be from almost no organic matter to almost pure organic matter. And so it's tough. Again, like I said, if you look at one of the papers that's referenced in our paper, it points to a system, and they've got a really nice, it looks like a texture triangle. And it's they use the right texture triangle, by the way, a right angle triangle. So good for them. But it's calcium carbonate, I think, or organic matter, and what was the third one? Mineral content. So there's an entire system to classify these deposits, which is why I hesitate to get into the really fine details. The next one was, I side with Richard's perspective. While organic carbon is useful, the genesis of the material is more important. And okay, so thanks, Jordan. Yeah, I think that we have to think of it from a genesis perspective. How are those materials deposited and what's developed in them? And thank you, Paul, for those comments. I think, I tried to, you expressed that much more eloquently than I did. Well, genesis is implied through the features. Yes, this is true. And so, yes, in my email after the last meeting, I tried to express that, we have got to try to stay away from picking apart the proposals on the fine details and just agreeing on whether or not we think that it's an incremental update that's worth including in the manual. And then, if we think we need to study these things in more detail, I invite anybody to reach out and say, hey, we need to do this, and we can put together some more work that would look at some of these finer details. I'd be happy to do that. But I do think that we need to, as we review these proposals, make some decisions on whether or not these things are incremental improvements that we want or not. Richard, do you have a comment?
Yeah, mine is specifically, you've proposed at the subgroup level to insert this new subgroup option for the PD organics, the tariff limit. What was the logic behind just inserting that there? And then we go through some terics, and then suddenly we come to a limnic again. We go teric, and then teric, humic, teric fibric, teric mesosalt, for example, and then limnic. Why the separation between the teric, limnic, and
because that's how the entire subgroup classification works.
Yes, I know.
Like all the terics have to be up top, and then the non-terics below. And that was the problem with describing these soils that we showed examples of that have, because as soon as you ran into a teric, you had to call it either a teric, it was either humic, mesic, or fibric. You couldn't include limnic with teric at the subgroup level. So if you look very carefully, a limnic feature within the organic order at the subgroup level is currently only expressed at the family level. But nobody uses the family level, first of all. And second of all, why do we allow great groups for OF, OH, and OM materials, which are all organic horizons, but we don't allow for an OCO horizon, which is also a designated organic horizon? And so why do we exclude one of our organic horizons as being diagnostic within the great group level as well? And so that's why in the subgroups, it's inserted right at the top.
Yes, I'm seeing that.
And then we're trying to parallel the teric subgroups with the non-teric subgroups,
Yes,
the
I'm seeing
same
that.
order of the secondary features that are described. And any other questions, Paul? Paul Martin? Muted?
Not so much a question as a comment. I'm in agreement to accept the proposed changes on the basis that we have an established land use challenge that is not being captured well by the system, which has been demonstrated by the paper. We have a demonstrated distribution of these kinds of soils in the Canadian landscape, and we have some inferences as to undocumented distribution. So we have that. And thirdly, on the basis that it is an improvement over the status quo in terms of delineation and capture of these materials, regardless of the, not necessarily erroneous assertions of, from Constantine et al. With respect to the strict interpretation of these materials relative to the rules and guidelines. I think that's a dialogue that obviously will continue. But in any case, I see this as an improvement in the system. I agree with Richard that the system is not meant to be static. But that I don't think in committee here right now we have the tools and the data to support going into this beyond this level of depth at the moment.
Constantine.
I actually agree with both of the polls, with Paul Sanborn saying, yeah, it's a good stage, and it could be next stage to modify something deeper, but at this point it's a good stage, and I actually agree with this article. It's a good improvement to the system. So that I'm with Paul Martin. Yeah, I support this modification, and I think we just need to work later on, consider it deeper, and that would be edition 5 or whatever it is.
Yeah, we'll get 4 out the door first, and then we'll start talking about 5. Okay, we got one more comment here from Richard.
Very small detail. Why did you use greater than 12 centimeters in the Terra Limnic for the Limnic layer, and in the Limnic layer down below it's greater than 5 centimeters? What was your logic of going to 12 as opposed to using the 5?
I'm not sure. I'll have to revisit it. But so the reason why, so 12 versus 25 centimeters is
12 versus 5.
Well, no, but I mean in the other organic materials. So so if you have a humic fibrosol, for example, versus a mesic fibrosol, the thickness criteria is different, and that was just reflecting those thickness differences. And I think that so I'd have to just revisit that in terms of why we went with 12 instead of 5. I mean, a limnic horizon, well, 5 centimeters is for in the limnic, the limnic profiles as opposed to the teric limnic. So yeah, we would probably keep that consistent, to be honest with you. But remember as well that in the, yes, well, yeah, I will, that's something we can revisit, and I'll have to revisit it in detail.
I'm not being critical one
No,
way or the other. I'm just
no, I can't
why-
remember.
why-
I have to go read my paper again.
The difference.
But yes, so the depth criteria, Richard is asking, why is it 12 centimeters? Why is it not 5? Because in the Limnic subgroups themselves, it's a 5 centimeter criteria, and then in the other ones, it's in the Taric, it's 12. The Taric Limnics that we propose, we use 12. So I'll have to revisit that, and that might get changed to 5 centimeters, but there might be an actual rationale for that.
Well, the 5 centimeters is to define it as existing Limnic layer, and it it is, but it does not affect classification yet. It has to be thicker.
Yes.
And I think 12 and 25 would be reasonable numbers.
I thought 12 and 25.
Less than 5 it's not recognized.
Yeah, I thought that was the 12 and 25 are the criteria for the subgroup differentiations, and 5 centimeters is the definition to recognize a Limnic horizon. It has to be at least 5 centimeters thick. So we'll revisit that. Kevin?
Yeah, just very quickly, I think we'll probably need to wrap this one up, but it sounds like you've got the marching orders to carry on with this, but now that you do, you'll probably just need to revisit it, like you say, and fine tune as needed. But it's with the idea that yes, it's going to be included or incorporated more or less as described in the paper.
Yeah, so the way that we're gonna proceed, I think, Kevin, is because the last meeting we ended and we didn't really get anywhere with the 2 first proposals we were discussing. There was a lot of back and forth. So I think the way that we're gonna proceed is that I'm gonna send these out to the distribution list, to the email, as kind of formatted as resolutions with some rationale and then the proposed change. And then there'll be a link to go to a site and register your vote and any comments you might have. And then we'll take that and we'll basically come up with what's going to be the final wording, I suppose, for what's going to actually go into the book. And then we'll have a chance to revisit probably all of those at the end of the process to make sure that everybody's still comfortable with what's gone in, because as you know, as we go through, for example, some of the proposals for changes that we'll see later might affect some of the proposals that we're talking about now. And so there's going to be a little bit of back and forth to adjust possibly some of the things that we're dealing with. And I think we just have to deal with the topics one at a time, and then we can then deal with their interaction at the end to see if, one thing changes, we need to change something else. Rafael?
I'll say it very quickly, but I think that the 12 centimeters comes from the fibrosol grade group. If you look, example, at the humic fibrosol in the Orange Book, it says other fibrosols that have a humic layer at least 12 centimeters in thickness.
It has to do with the difference in the decomposition of the organic materials. If it's fibric versus humic, then you only need 12 centimeters because they're highly contrasting. Whereas if it's mesic and humic, then you need 25 because they're closer in the terms of the decomposition. So they set the thickness thresholds different to recognize those secondary materials at the subgroup level. Yeah, you're right. Rongwei?
When we create a new soil series or new soil variant, we have enough soil acreage. For example, how large it is, for example, 2,000 acres to have a new variant. And do we have this kind of the figure for create a new subgroup? How many?
Yeah, the criteria were always, so the criteria at the series level were always based on a certain area of a soil. Whereas at the higher level, I think the higher level, so the higher taxonomic, so order, grade group, subgroup, are in a way a little bit more conceptual in terms of, do these things exist within the landscape and can we observe them? Whether or not you use a series to represent something or a variant is a good question. So I believe in, yeah, I know Jim is Jim's growling at me from the corner. In Quebec, like where those soils were mapped and some of the soil survey work that was done in the late 2000s, those were mostly noted as variants. But that's because of the limitation in the taxonomic system that didn't allow them to be classified any other way. So at the family level, they can be classified, and that information was included at the family level for those soils. But I tend to feel like everybody in the world ignores the soil family level, but they shouldn't. And so at the soil series level, they weren't assigned their own soil series. They were variants of other soils with which they existed in complexes. And so I can't answer your question in terms of what the acreage should be to acknowledge these things within our taxonomic system. I believe the guidance before was only given at the soil series level, which is interesting.
Okay.
Okay. So do we want to try to tackle the soil drainage? We might as well take our 30 minutes. We might not get very far with it because I think it's going to be a bit more of a. I'm going to hang on a second. I got to share screen here first. What's that? No one? Are you going to go into presentation mode? It's probably going to show up over there. Which version are you guys seeing? The full screen or the presenter mode?
Presenter mode.
Presenter mode. Yeah, I can't see you. You guys can't see my cheat sheets. Hang on a second. Stop share. Screen 2. There we go. All right, now you should see the full thing. Are we good? Okay, so
yes.
I'm going to try to fly through this because I'm assuming that everybody did their homework and read the paper in detail and wrote down notes and everything. So a little bit of background. So we were looking at soil drainage in non-redoxymorphic soils. And so there is no formal definition of soil drainage in the Canadian System of Soil Classification. It's in the additional field manual for describing soils in Canada document that sits as a separate document that we refer to in the Canadian System of Soil Classification, and that most people can't find online when they need to go find it. Soil drainage class is one of 5 factors used to define what's called the soil moisture regime. So that includes drainage, aridity, hydraulic conductivity, saturated zone, and seepage. As we know, there's 7 classes. And since the Expert Committee on Soil Survey was dissolved many, many moons ago, there's really been a lack of consistency in how we assign drainage classes, and various provinces have their own standards and reference flowcharts. So just a couple of examples here of differences in assigning soil drainage. So Ontario has a very different system, well, somewhat similar, but different than British Columbia. And we can see some things in the redoxymorphic soils that are a little bit intriguing, like gray models, as opposed to, orange models or bright models, or anyways, there's some color things in here. What we're really focused on is the assignment of drainage classes in those soils that don't have hydromorphic properties. All right. So we're not really concerned in this work about very poor, and imperfectly drained stuff. Richard's leading a group on that work. We're more interested in moderately well to very rapidly drained soils. So as background, drainage classes can be split into 2 groups. Again, redoxymorphic and non-redoxymorphic, which we just talked about. Commonly imperfectly drained soils are referred to as glade phases of well-drained soils. Poorly drained soils can either be glade subgroups, glacials, and also organic soils. And very poorly drained soils are either glacialic or organic. Drainage classes are linked to morphological characteristics that we can describe in the field. Presence of models and glaying. And it's really important to note that drainage is not directly linked to soil classification. And so there's no direct link. A poorly drained soil is not necessarily a glacial. So soil drainage in non-redoxymorphic soils. So essentially, if you look at the definitions of drainage classes for the non-redoxymorphic soils in the field description book, they're defined based on their available water holding capacity, because there are no morphological features that you can describe to tell you if something is rapidly drained or very rapidly drained. If we look at those definitions, very rapid is less than 2.5 centimeters of available water. Rapid is 2.5 to 4 centimeters. within the control section. That's an important thing. It's within the entire control section. 4 to 5 centimeters of available water for well-drained soils and 5 to 6 for moderately well-drained soils. If we look down at the bottom at the table here, we can see available water holding properties of Manitoba soils. We'll talk a little bit about this later. One of the things that really we don't really pay very much attention to in terms of available water and any soil water holding characteristics that we look at is the effect of sand separate distribution within those coarser textured soils. So we can see here coarse sand can hold only 6 or so centimeters of water, whereas a very fine sand will hold 12. Again, that's over the well, actually this is on a percent basis, percent by volume. So this is not over an entire profile, unless your profile is homogeneously coarse sand. All right. Some more background. There's some interesting connections between soil drainage as defined in that description manual by Day and available water holding capacity manual by McKeague, 1986. So we can see they use the same terminology, kind of. So very rapid and very low available water holding capacity, rapid and low, well drainage or medium available water holding capacity, and moderately high and moderately well drained. And if we kind of compare the two, I'm not going to do it in detail, but essentially very low available water storage, right? And that connects with a very low class for McKeague. And so we really think that there was an error in transcription or moving the information from one document to the other because they don't really align except for the class names. And so, and you can see that available water holding capacity based on McKeague is, twice that of what's in the drainage classes definitions by Day in 1983. And then lastly, again, I'll point to the fact that, the sands, the loamy sands and the sandy loams can be further refined, right, by looking at the distribution of the sand separates. We can see here that available water holding capacity can be affected by the coarseness of the sand. And if we look at, we've got some data that we've been looking at for hydraulic, or for KSAT, hydraulic conductivity of soils. And we're seeing a real effect on hydraulic conductivity as well, based on the sand separates that we're looking at. And so these things all factor into how we would assign drainage because they affect water holding capacity. So how did we do this analysis? It was a totally simulated exercise where we generated a soil texture data set. We combined all the unique combinations of sand, silt, clay that sum to 100%. We did that in steps of 1. So that's 5,151 combinations that make up the texture triangle, essentially. We then assigned each one of those records a texture class. We did the same thing with the sand fractions. And so for the sand fractions, we did a simulated data set where all the sand separates combinations in steps of 5% that sum to 100 were included. So that gives us 10,626 combinations. And then if you multiply those two data sets together to give you the full picture, you end up with 6 million different unique records in that data set. And it should also be noted that we have 5 classes of sand separates, but when we roll that up to the texture class, we only recognize 4 texture classes that are modified. So there's no very coarse, there's only coarse, right? Coarse sandy loam, coarse loamy sand, coarse sand. There's no such thing as a very coarse sand at the soil texture class level. So then, since the drainage is supposed to be based on available water holding capacity, we decided to use a pedo transfer function. We used the equation of Halischuk, did some work in Manitoba. The reason we chose Halischuk is because they actually look at sand fractions in their calculation. So they incorporate fine sand and very fine sand in the pedo transfer function. Notice that medium sand, coarse sand, and very coarse sand don't really factor in. And that's probably because they don't hold a whole lot of water in a soil. And then the last thing we did is that drainage class was assigned to each of the records based on the available water holding capacity ranges. So we calculated available water holding capacity, and then using Day and McKeague, we assigned what would be the drainage classes from very rapid down to moderately well. And then essentially what we did was a majority rule. So we took all of the same texture And then we assigned the drainage class based on the most assigned drainage class to that particular texture class. So I always find this an intriguing graphic. We look at the texture triangle a lot. We may not recognize the fact that almost 50% of the triangle is contained within the heavy clays, silt loams, and the clays, which is a huge amount of the texture triangle that's assigned to just those 3 texture classes. So I know there's reasons for these limits, but it's always good to identify that that the distribution of those points within the texture triangle are not even between the classes. So then if we were to assign drainage class based on day, all of the soil texture classes from heavy clay to sand would basically all have to be classified as moderately well drained based on the available water holding capacity that are defined in our current system, which we know is not true. When we use McKeague's equation from 1986, we can see that there starts to be some variability. So we can see that the sandy loams, the loamy sands, and the sands start to get some little bits of very rapid, some rapid, and some well drainage in there as well. Another thing to note that I find interesting in this is the sandy clay loams and the sandy clays. The sand that's in there really has an effect on the available water holding capacity of those soils. We typically lump silty clay loams, and sandy clay loams together as what we call moderately fine textured soils. But we can see here that the sandy clay loams behave quite differently, and maybe they don't actually belong in that grouping. Same thing with the sandy clays. So the sandy clays behave quite differently than the clays and the silty clays. So then if we look a little bit closer and we start grouping these things by the coarser textured soils by their further refinements by acknowledging the sand separate distribution. If we use day again, we can see basically everything still remains moderately well drained. And then if we use McKeague's values, we see a very different story. And so we can see that very rapidly drained soils that are just made of the fine fraction certainly don't really get to very rapidly drained ever on their own. And we'll see that in the next slide where we start to look at including coarse fragments and profile thickness into these. We can see that moderately well becomes important for just the finer textured soil. So very fine sandy loams and the fine sandy loams. Okay, and this matches up with what we've already looked at. The other thing that's really interesting, I think, about this plot is the distribution. And so this is all of the possible combinations in our texture triangle that can give you, for example, let's just look at the sands, very fine sand texture, fine sand, sand, and coarse sand. Note that 60% of the combinations of sand separates that can give us a sand texture end up giving us a coarse sand. So there's a really uneven distribution even in how we assign the sand separates to these 4 different subclasses of sandy textures. And you can see that's true across the board for the sandy loams and the loamy sands. And so our system is not, it's an interesting thing to look at in terms of how uneven the classes are here, and then also how uneven they are in the texture triangle. I'm not saying they should be even, but it's just interesting. And so essentially the end of the work is to propose a standardized approach to assigning soil drainage class in non-redoxymorphic soils. So essentially these are soils where you cannot see any mottling or glaying. And so then how do you assign a drainage class? And so this would be kind of our proposed matrix for assigning drainage class. And this could be something that would just go into the Canadian System of Soil Classification, and it would standardize the assignment of drainage class across the country when we're looking at these types of soils. Note that we've also done kind of some rough estimates in terms of either the inclusion of coarse fragments or depth to bedrock, because remember, when we're dealing with available water holding capacity for soil drainage, it's the entire soil profile or the control section. And so for shallow soils, obviously we would get better drainage, I suppose, as the bedrock comes closer to the surface. Same thing with the addition of coarse fragments. We reduce those fines and we have those coarse fragments in there. We're reducing the amount of volume that can actually hold water in that soil. And so you can kind of see down here, if you remember, I highlighted the sandy clay loams and the sandy clays. We can see how they do perform slightly differently, for example, than the clay loams and the silty clay loams. If you're looking at the sandy clay loam, you can get a well drained and then some rapids, but then you look at the clay loams and silty clay loams, you end up kind of at the moderately well when there's no coarse fragments and you have a full soil profile. So this is essentially that was our end proposal. Essentially, there's no guidance in the CSSC for assigning drainage class to these soils. Provinces have kind of done their own flow charts, and they follow their own rules, so there's no consistency. Ranges in available water holding capacity in the day manual should be disregarded. They're completely wrong. Those in McKeag are much more accurate and more suitable for the purposes that we're trying to use them for. And so essentially we go back to this matrix. Essentially, this is what we propose. We add to the Canadian system of soil classification to standardize our assignment of drainage classes. Thanks. That's it. End slideshow. What do we see now? All right, so I'll put the chat up. So are there any comments on the soil drainage? Constantine put his hand up, so I'll go to Constantine first.
No, Paul was first, for sure.
Go ahead,
That's
Paul.
all right. Go ahead, Constantine.
I have just very quick comment that the number of classes that you found different between finer fractions and coarser fractions and so on is because the fractions are designed in logarithmic scale rather than linear.
Yes, you're right.
So it's if you plot the same in a logarithmic scale, they would be even. Anyhow, otherwise, good approach, and yeah, I'm looking forward for that.
Yeah, and so one of the comments is that you might not be able to define available water holding capacity in the field, and that's exactly why we provide that matrix of estimated available water holding capacity to make those decisions. And so we base it on pedo transfer functions, and of course, like anything else, if you have actual data, then I would defer to the actual data. The lookup table is guidance to be able to try to standardize how you would assign drainage in the field. So Paul Martin.
Yeah, hi. Again, another very well thought out paper, a very straightforward suggestion to inclusion. I like it as a base reference tool, especially for teaching what class to expect in given materials. I'd like to discuss your assumption of a 1 meter pedon and the lack of restrictive layers. Have you given any thought to modifiers to address some of the things that, we know we experience out here for sure, where you have, fine, one example, fine laminations that lead to slight increases in moisture holding capacity that are strictly the difference between coarse sands and fine sands. Another would be a location we surveyed, which was basically a D-ecosite aspen mix on straight gravel, because there were basically degraded oil sand tar mats laid in that were restricting water percolation in the profile long enough to turn that material into essentially a moderately well-drained profile. I don't know how you would handle that, but have you given some thought to structure around those kinds of modifications, or would you leave it strictly up to the surveyor to document those and justify their calls?
Were you going to answer that? No.
Oh,
you have
yeah,
another comment?
That's got a perspective. I don't have an answer.
Richard has the answer.
If I need a
No, I don't think so. I would think that, yeah, it's to the discretion of the surveyor in the field. I mean, you have to determine what that control section is, right? Based on the information that you have in the field. And then it's a good question, Paul, because you can have gradation of materials. We're not going to have a homogeneous soil profile, and we know that. I think that if you have these major changes in materials, that you'd have to maybe think about potentially weighting those things differently and how you come up with the overall drainage. Now, I believe there's also some additional guidance, is there not, in the manual on dealing with lithological discontinuities and soil profiles and how you assign drainage class. So that is an excellent point, Paul, that Jim and Richard and I should revisit the guidance on how you assign drainage to these kind of layered materials or layered deposits. There is guidance in there. I don't know off the top of my head, but Richard?
I think there might be a possible, I think there might be I'm giving the more esoteric examples, but certainly where your pedon doesn't reach a meter, where you're dealing with bedrock within, X centimeters or some sort of impermeable aquicludic layer, even if it's frost. We have some funky things that go on in the landscape based on that are almost dichotomous within the profile in terms of drainage. So I don't think you're going to be able to solve all these, but some guidance would probably be welcome.
Yeah, Richard.
So I think we have to reflect that when we're utilizing that part of flowcharts that deal with redoxymorphic feature primarily, well, do we have some layer of organic matter, or do we have the modeling or the glaying? We're looking at characterizing and assigning a drainage class to the profile. And it's as you brought up, Paul, sometimes you might find a relatively uniform texture from top to bottom in your control section, but more often than not, and even from soil development, that's not going to be the case. I know that in the context of moisture regime classification that the ecologists are using here in Ontario, they do have a strategy whereby they essentially identify what they consider to be the most influential layer. And so they go progressively through the layers and determine, well, is this layer more influential than the other one in terms of its retentive capacity? And maybe we have to also be thinking along that lines in terms of establishing a standardized approach to dealing with layered materials. And the other thing that this also doesn't consider, if you go back to the McKeag document, is any kind of structure in the soil system, which it could profoundly change how the drainage is going to be taking place. We're simply working with unstructured material of a uniform consistency. When we go to the redoxymorphic, that's sort of all been integrated for us in the profile. And we're not at this level of trying to ferret out, well, what would be the behavior of the material?
Well, that's fair enough. Thank you.
But it is a conundrum that we have to address. I think we have to think about how do we handle layered materials, which is more common than not. We can talk the detail on the single materials, but how do we build that into a layered profile?
I think it's like, and I do believe that it's actually referenced in day how you make that decision. So we just have to look at that to see. But yes, Rongui.
I agree. That's a good presentation, and also I suppose to incorporate it with a new classification. And one question is, you just mentioned about that this soil profile, most of those profiles not homogeneous, and maybe the color overflow and overtube, something like that. And also another question is, how do you deal with the water table? For example, if some of the soil have a lower water table in the 1 year, and another year have a dry year, maybe water table is low, and it also affects our definition for soil drainage in the field. And for example, in Manitoba, we have lots of the sand, we call it wet sand. Some year it could be poorly drained, and some year it could be, well drained, or multiple well drained. And how can this model, what your concept fit this kind of the situation?
I was trying to let Richard take that one. Yeah, there are going to be fringe exceptions to these rules. I guess what I would say is that, you know, the chart that we're providing is for guidance to try to standardize things. There are going to be these fringe cases where you're going to see something in the field that doesn't fit the rule. I think that soil science and general pedology is all about things that don't fit the rules, to be quite honest. And so I think it's something that we're used to, and certainly, yeah, I mean, you can have these soils like you've described. You know, are they the norm? I would say probably not, right? And so this chart is guidance to try to standardize things, but it doesn't mean that you have to call it, you know, moderately well drained because it's a loamy fine sand that's 100 centimeters thick and it's, you know, the same texture top to bottom. This is just an attempt to try to standardize things so that we can, at least we're looking at the same charts when we're thinking about what our decision is in the field. We have the same information that we're all looking at.
Mhm.
I think there's also, Richard, I think there's also a subtle difference that we have to, and whether it in functionality it makes any difference, but here we're actually describing what how we would categorize that soil material. But you're absolutely right that we're dealing with this soil material within a landscape context, and you might have exactly the same soil material at the bottom of the slope as you have at the top of the slope, but because you've got a drainage or a groundwater table, the actual hydrological regime that you're dealing with is going to be different. But the property of the soil itself, the behavior of the soil material itself is really, I think, what the focus of this particular work was, as opposed to how a particular unit of soil is actually being expressed and behaving in the landscape context.
Mm-hmm.
Yeah.
We've got Kevin.
Yeah, just to follow up a little bit on that, I think we have to be careful not to confuse, you know, wetness on any given day you're out in the field with drainage class, because we all know that a well-drained soil can be saturated and ponded on any, you know, under any given conditions, or not any conditions, but you know what I mean, depending on the time of year there, or the week after 24 hours of rain or something like that. But anyway, in your table there with the modifiers, and this I think kind of references the last comment that I believe it was Richard that I heard talking, was that slope could be a modifier as well as depth to, you know, to an impervious layer or bedrock. I think it was in your table. So percent slope and or slope position is something that you can, you know, easily read in the field and have that as a modifier potentially as well, because, you know, a soil that has a certain characteristic texture and depth, if that's on a 30% slope, is going to have a different drainage class than the same soil, you know, otherwise on a level ground or whatnot. And that's a feature that's easily, I think, potentially at least, easily integrated into your table at some level.
Thanks, Kevin. Richard has a comment on that.
In fact, yes, the moisture regime framework that's used by the ecologists in Ontario does look at slope of the landscape as well. And the example that you gave, impervious bedrock, if it's flat, the water, supposedly perfectly flat, the water falls and it's not going anywhere. You put a little bit of slope on there, and the reality of the moisture regime is quite different.
Yeah.
And last very quick point is, I wonder what the value is between rapid and very rapid. To me, that almost sounds like dead and very dead. I mean, it is what it is. But anyway, that's a bias that I have on those two.
Yeah, it aligns with so many other systems that have done the same thing, right? And I think that yeah, and I think it's part of soil science in general. Like if you think about like stoniness classes, like exceedingly stony and excessively stony, well, that's just too much rock to farm. That's what we're trying to say, right? So, but anyways, yeah, I understand. Yeah, the terminology is not always very fun to deal with, but Yeah, so we've got time for one, Kent, go ahead, please.
Yeah, just a quick comment. I work in the sewage industry and soil classification. And what they've discovered and find is that based on the texture and the structure, different horizons are going to allow different amounts of moisture through at any given time. So is that considered in here at all? Or are we just defining the whole profile meter deep?
Yeah, so
Like an
if you,
average.
yeah, if you read the definition of drainage in the Canadian system for the non-redoxymorphic soils, it's based on available water holding capacity within the control section. So not a lot of people pick up the second book or nor read because it's hard print to read because it's all typeset. But yeah, and I mean, and we've had arguments before as well within the room about, you know, while drainage is not only about available water holding capacity, it's also about the hydraulic conductivity of the soil and how long that water actually stays there or moves out of the soil profile. And so I think there's probably, if you look at the American system includes available water holding capacity and information about hydraulic conductivity of soils in their definitions of drainage class. And so they've got an extra component in theirs that we ignore in our system. So our definitions are almost identical, except for the KSAT discussion. So yeah, it's a good point.
Okay.
All right, well, we're at time. I actually am surprised that we actually made it through both of those topics. I really didn't think we would, but thanks everyone for joining. Look for some emails about the discussions we had a month ago and then about the ones we had today coming through in the next few weeks to start voting on these things and providing additional written feedback if there is. Remember as well, there's that online form. I've seen some people have been putting material on our online form with other topics that they would like to propose and discuss. And so please keep adding to those. We will visit those closer to summer before we go to the CSSS. And so thank you again to everybody, and we hope to see you at the next meeting.
Dan, thanks everyone.
Thanks.
Once again, thanks Dan and Raphael and everyone for putting this on.
Yeah, I'll second that and enjoy the weekend, folks.
Family Day weekend, free fishing in Alberta.
Yeah, we're good.
Yeah.
Okay.
Let's turn.
Thanks, everyone.